We are going to see about linear programming in decision taking. Okay, so as of now, we are discussing about the topic decision taking. What is decision taking in operation management? What is the use of decision taking? Okay, and what are the techniques to be used in decision taking? Like earlier in the video, we have seen the break even analysis. What is the break even analysis? What we are going to do in the break even analysis, how to find break even point by using the volume of production as well as the cost produced, right? So that operation management decision taking one technique we have seen in the last video. Now this is a linear programming is another one. So where it's a mathematical optimization technique. So optimization, what do you mean by optimization? Optimization is that which is having optimize the resources we use. Okay, so how we can effectively do a thing, that is what normally optimization here. It's a method of to discuss about or to find the to maximize the profit and minimize the loss. You see some companies, they may have two or three variables. That's what it depends upon the variables. Already we have discussed about variables with certainty, variables with partial certainty, variables with uncertainty, like so where there is no variables, detailed variables is getting, will go for flip coin method or astrology method. But here we are having some procedures to be followed, optimization technique. If we have to follow the procedures, so that is called mathematical programming. So here any program, certain decisions need to be made. Either that is what only thing is in industry, either we have to maximize the profit or we have to minimize the profit. So problem will come. So decision making is very important to decide what is it, to make a decision when there is a problem. So first of all, we should know what is the problem and what are the variables out there which affect the problems. Okay, so problems in the sense, some variables may affects the maybe the factors for the problems, or we can control the problems. So first of all, we should find the factors, and through the formulation of this LP model, we are going to do it. So let me solve a problem here. Let me see a problem here. In the problem, a manufacturer produces two types of models, M1 and M2. Each model of the type M1 requires 4 hours of grinding and 2 hours of polishing. Okay, whereas the model 2 M2 requires 2 hours of grinding and 5 hours of polishing. So manufacturer has three polishers. Each grinder works for 40 hours a week and each polisher works 60 hours a week. So profit on M1 model is rupees 3 and model M2 is rupees 4. Whatever produced in a week is sold in the market. How should the manufacturer allocate the production capacity to two types of models so that the maximum profit in a week? So clearly here we come to know that there are two models a manufacturer is making, and there are two processes. One is grinding and polishing. So in M1, how much hours it is taken for polishing and how much hour for taking for grinding, they are given. As well as for M2 model, how many hours for grinding and how many hours for polishing it is taking, they have given. And how many hours the grinding machine or polishing machine works, that also to be done, it's given. Now we have to make this as a problem statement. Okay, so whatever they have given, that we have to cumulatively, we have to make it as a equation statement, that is with the decision variable. We call it as identify and define the decision variable of the problem. So x1 x2 let be the number of units of M1 M2 model. So how many units we are going to do, that is the number of units of the model 1 and model 2. Define the objective function. This is the two things we have to do it. In the objective function, what is that? Question given is how to maximize the profit. What is the which question is how should a manufacturer allocate the production capacity so that he makes a profit in a week. So here we have to give a statement that maximize, max is equal to 3x1 plus 4x2, right? So that is 3x1 number of here earlier in the problems clearly we see that 3 M1 for the two types of model M1 and M2. M1 requires 4 hours of grinding and 2 hours of polishing, whereas M2 requires 2 hours of grinding and 5 hours of polishing. Manufacturer has 2 grinders and 3 polishers. Okay, so each grinder works for 40 hours and 60 hours. By using this, and we are having a profit of M1 is 3 rupees for M1 model and 4 rupees for M2 model. So when I am going to maximize the profit, I am concentrating on cost profit. It is given, the statement is given 3 rupees for model 1 and 4 rupees for model 2. So which one, that is maximization of profit. Max Z is equal to 3x1 plus 4x2, like that I am writing. Next, state the constraints which the objective function should be optimized. Maximization or minimization. Here grinding constraints given, what it is, grinding x1 x2 in this 4 hours it requires for one model 1 it requires 4 hours of grinding and 2 hours of polishing. So I am writing as 4x1 plus 2x2. Okay, so and that's the the manufacturer has 2 grinders. I am going to concentrate on only grinder first. We have to concentrate on grinder, then we are going for polisher. So take a grinding machine. M1 requires 4 hours of grinding, M2 requires 2 hours of grinding. So each grinder works 40 hours per week. Alright, so that we have to consider, and polisher works 60 hours. So 40 hours of a grinder. Now only I am taking grinder. So grinding constraint. First module 4, second module 2. Okay, 4 into x1 plus 2 into x2 less than, or that is how many hours it can work. So each grinder works for 40 hours. So there are 2 grinders. One grinder works for 40 hours. There are 2 grinders. So 2 into 40, 80. So that's what the equation here gives, 4x1 plus 2x2, right? So this equation is this one, and number of machines per week, available grinding machines per week is 40, so it is 80. And polishing constraint. Okay, polishing constraint, that is say here what it is, the polishing constraint is given by 2x1 and 5x2 is equal to 180. How it comes? Because it's given there are grinding machines, 3 grinding machines are available and it is working for 60 hours. So 3 into 60, 180 hours. That's what it is given as 180. Okay, and 2x1 plus 5x2 is the already it is given in the problem statements. For model 1 what is that, and model 2 is that. So finally we will have an equation that maximus Z is equal to 3x1 plus 4x2, and subject to the constraints 4x1 plus 2x2 lesser than 80, 2x1 plus 5x2 lesser than 180, x1 comma x2 is equal to 0. So by using this equation, now what we have to find is x1 and x2. Okay, equation number this is the first thing. A problem should be made into a problematic, what is the equations. So whatever it is given in the question paper, that is a problem. Normally they will give like equations, but here we will give M1 4 hours of grinding, 4 hours of 2 hours of polishing, okay, and 5 hours of polishing, like that it is given. By using the 5 hours we will make equations like that, and these equations we have to form like this, maximizing the profit Z and this constraints. So finally this we will have. So by using this we have to calculate the x1 and x2 for different things. Here we have to go into apply this one by considering x1 as a 0, what is the value? By considering x2 as a 0, what is happening? So x1 x2 we are going to find some set of x1 x2s, and applying this x1 x2 in this Z equation. So which x1 x2 will give maximum profit? First of all we have to find x1 x2s, and by equating by using these equations. So then after this, considering x1 equal to 0, you will get x2, and here x1 is equal to 0, you will get x2, like that. Once if you are assuming x1 is equal to 0 and x2 we will get, then what is there are coordinate points we will get as x1 x2 coordinate points. So these coordinate points, and this is x1 and x2, we will use it here in the maximum position, so that we will get which is the maximum value we are going to find, and which x1 x2 will be useful. So that's the graph we have to draw it. And now this is the method how to make the problem into statement equations, right?